make this one. Oh, there you go. Okay, cool. Morning, everyone. So my presentation is around 10 years of AppSec, and it's all been fixed by now. Why aren't they all, doing something far more interesting than AppSec? A little bit about me, the obligatory. You have to have one of these. So I've been in IT information security for the last 15 years. I actually started in IT security almost exactly 10 years ago with a bank called Intelligent Finance when they launched one of the first full-service web banks. I'm director of Securi-TAY, small testing company, local testing company. And I'm the OWASP Scotland chapter lead. Just a quick curiosity, I always ask this, start every presentation. OWASP, ever heard of OWASP? Cool. Excellent, that's better than I usually get. So I start off with a walk down memory lane. We have Apple's website. This is them from about 10 years ago. Let's change a little bit. The Facebook, that's how Facebook started. That's actually slightly later, that's 2004. We've got Friends Reunited, which has come and gone in the last 10 years. And what's that? Anyone know? Google. No, that's Wikipedia, would you believe? That's the number of topics we used to have. So about 10 years ago. So this is just going to say, we've all come along, well, I'm not sure how much Yahoo's changed, but most sites have come along a really long way in the last 10 years. And it's changed quite a bit. So a brief history. Many of today's top sites don't exist. Facebook didn't exist, Twitter didn't exist, LinkedIn didn't exist. A lot of new stuff has happened, and ISDN is king of home internet access. So I don't know how many of you remember ISDN, but I remember BT Home Highway and getting the massive total of 64K and paying a very large amount of money for the privilege. And Code Red is the biggest security issue of the day. 10 years ago, just over 10 years ago, Code Red started, and it was the big issue of the day. And it was actually quite interesting. On its best day, it compromised 300,000 servers, and that was an IIS bug. Recently, there was a web bug for mass SQL injection, which I looked at, was the new one that is doing urchin.js. Google says 617,000 pages compromised with that problem. No one's even heard of it. A couple of blogs have mentioned it. It's no news at all. Yet 300,000 servers 10 years ago was absolutely the biggest story for months on end. It was like, IT security be all and end all. It was the main thing. So, what do we do? 10 years ago, Internet Explorer. When I first worked in e-commerce, no one would test for anything other than IE. Because what was the point? They had 90+% market share. Firefox was there, but that's just about it. SQL injection just starting to be discussed. 1998, SQL injection started, so it's been around for about 13 years now. Papers started coming out around 2001. And OWASP started 10 years ago, September 2001. And it's been fairly strong since. So what's changed? What's actually changed? Have we moved on much, or are we right back where we were? Prominence. 10 years ago, most companies would not worry too much if their internet access was down. It'd be a problem, but it wouldn't be critical. These days, if you take most companies' internet access away from them, they will collapse in fairly short order. I looked up, e-commerce is up to 50 billion in the UK from 2 billion 10 years ago. So, you're talking about a huge amount of money. People completely rely on this stuff. It's not something now where, it's a nice to have. It's something which if you don't have, it's really, really bad news for your enterprise. But what hasn't changed? Well, there's no effective government security regulation. You look at the government, you say, right, what mandate does a company have to actually do web app security properly? Well, you've got the Data Protection Act, which basically says do good stuff with data. If Principle 7, you will actually maintain adequate security over personal data. I'll be honest and say, in my experience, that doesn't get a huge amount of prominence. People, yes, they play lip service to it, but it doesn't actually mandate exactly what you have to do. As a result, people will do as little as possible. Financial industry, they've got the FSA. Well, if something goes wrong, you can guarantee the FSA will come and do bad things to you. But beforehand, the only closest thing you've really got, which isn't government, is PCI. Yeah, sorry.
Why are you expecting a government to regulate security? Well, government doesn't regulate whether I lock my house or not.
They do regulate other things like safety, though. So you think about company safety. So you regulate health and safety, for example. So a good example is the fact that it's not in companies individually.
Protect people from dangers.
Yes.
That they haven't got under control themselves.
Exactly, but most companies don't have a sufficiently strong incentive to do security right now. So they are essentially not.
But the problem is not the government.
But the government could fix it. They could say, if you don't take, because individuals have no power. I've got no power to say to Facebook, if if you don't do what I want from a security perspective, I'm going to not use Facebook. They don't care. Well, Facebook, Google, whoever. Somewhere you put your personal information. So it's something individuals can't solve. So you can say, should the state solve that problem because individuals can't? And it's that essential point you can say, well, should they be doing something about that? PCI, which is credit card, is the only vaguely close to, and people hate it. If you actually talk to anyone who has to deal with PCI, they absolutely hate it. But it is the best you've got right now. It's the only thing that actually says, when I say secure, I mean this. I mean, web applications actually have to not do have to be protected against the OAuth top 10, which is a dreadfully fuzzy phrase. Even though the top 10 is quite well defined, it's amazing what people can say. We test for the OAuth top 10. Our product checks for the OAuth top 10, even though that's not possible. No product ever could, but still say it. So it is much, much more important, and yet. So I looked at the OAuth top 10. It first came out in 2004, 7 years ago. And I said, what's actually changed in the OAuth top 10 in the last 7 years? One thing left, which is buffer overflows. So there's only one thing which has gone out of web app security in terms of things that actually moved, which is buffer overflows. And everything else is still there. Stuff that was an issue 10 years ago is still an issue now. Injection is, so I was reading the new Web App Hackers Handbook, which reckons it's still at 30%. I've seen estimates between about 15% and 30% of sites still with SQL injection. Cross-site scripting, to be honest with you, if it's 80-90, it's really, really high. Yet, this is absolutely not a new issue. This is something which has been going around for 10 years, which is SQL injection is well understood, cross-site scripting less so, but still. So our problems are still the exact same problems we had. Nothing has really changed that much from that perspective. And authentication, one of the major things is how do you actually sign on to websites? Not changed. Not changed not much. I mean, sites that do two-factor, Google, World of Warcraft, some corporate banks, some very high-value applications. But you still your personal bank still using username and password. Not really, and passwords are still king. So how many passwords do you have now? Think about 10 years ago and say how many passwords did I have for websites and how many did I have now? The only effective solution I've come up with, I used to do a thing where I'd say I'd have different tiers of password. So I'd say like, I don't care, I care a bit, I really care. And that doesn't even work for me anymore because I think, well, if some of them, I don't trust any of these mid-tier companies anymore, ones I kind of care about. So now I've had to go down password safe route. And I've had to say, right, I'm going to have an individual password for each one and I'm going to put them in a password safe. Because I reckon I've got about 50 or 60, easy. And I can't remember 50 or 60. And IT security is actually part of the problem here, because they'll tell you not to do that. They'll tell you have to remember it, and you have to change it every 30 days. And you find the person who can remember 50 or 60 different, unique, hard to remember strings, I'd change them every 30 days, and I'll find you a very odd person. A very, very odd memory. She's going to fucking memory. Game shows or something. Passwords are still a pain. And passwords are innately very, very broken. You're seeing now, instead of people attacking sites and compromising those passwords, as soon as they've done that, they're immediately running around the rest of the internet, trying those combinations. So password authentication is fundamentally a broken mechanism. But still, it's used as cheap. It's cheap and it's easy and everyone recognises it. Frameworks. So frameworks have changed in the last 10 years. If you think about the last 10, go back 10 years and it's Perl CGIs. And it's classic ASP and things like that. So largely, those have largely gone. If you ever test, I do security testing day in, day out, the place I still see those is things like embedded web servers. So if someone's got a switch or a router or whatever, and it's got an embedded web server, those still have CGIs quite a lot. So you get ASP, struts, Rails. All of these frameworks will help to an extent. They will protect your application from certain things, which is great. And I'm a strong advocate of using frameworks for web app security. If you want to, in terms of my testing, if I get a classic ASP app, I almost guarantee that I will find input validation problems somewhere because the individual developer had to go to every single field in every single page and validate that input, and no one gets that right every single time. Framework has some chance of stopping that happening. And it will handle some classes, so it'll handle some classes of issue. Like, it'll handle input validation reasonably. Some of them will handle authentication reasonably. Some of them will handle things like crypto reasonably. So that to a certain level, they're fine. But they can't help everywhere. One of the problems I see is you see ASP.NET applications. So ASP.NET developers get their input validation for free, and they get a lot of their authentication for free as well. And as a result, they kind of get the impression that they don't have to worry about security. So the framework has done security for me. I'm personally, as an individual developer, I can just carry on and get my pages out the way I go. As a result, the number of things like authorization problems I find in ASP.NET apps is quite high because they haven't thought about it. So they just slam the page out the way you go. There was actually an interesting article that was suggesting that ASP.NET applications are actually less secure than things developed in weaker frameworks, because the developers have got this mindset of, I don't have to think about this is someone else's problem. Yeah, they don't address business logic issues, they don't address authorization issues. And those are the best bugs I've ever found doing things like that. The things that companies probably care most about are things like authorization bugs as well. When I find them, they're the ones that people in the business go, what? You can go through the entire customer database and pull back every single person's record. That's a really nasty problem. And one the business probably they understand why that's an issue. They don't really understand, if I can make a box pop up on the screen, which is the standard cross-site scripting test every single person tester does, they don't know that, so what? So a box pops on the screen. If you say to them, I can get all your customers' data and I can take it away, they go, oh, I see what you might have a problem. Did anyone see the thing that happened in Australia yesterday? The worst thing was that some guy found one of that in a pension site, reported it to him, and he got a visit from the police. That's another part of security's problem, is that's still the company's reaction. The company, some guy takes his own free time, writes a proof of concept, finds someone in IT, reports it to him, and gets hassled from the police. Brilliant. And he gets told by the company in question, we're going to try and make you pay for any damage, we have to fix this. What? Yeah, okay, that's a different issue. Also, frameworks also introduce new issues, which is complexity. If you look at modern app dev and you say you're using a framework, and say you're using Rails as a good example. So I'm using Rails, and I'm using gems. And essentially what I'm really doing at that point isn't developing so much as plugging them all together. And I'm using jQuery. So I'm using frameworks for everything. I'm at that point, when you just dump that jQuery file in there, or when I dump that gem in there, you're using one piece of functionality out of it. You probably don't even know what all the rest of it does, let alone know where the security problems are in it. I mean, if you're developing an app and using a framework, who goes and reads the source code of the gems? If you're using Rails as an example, or if you're using struts or whatever else, do you go and read the source code? Absolutely not. You don't have time for that, because the whole point of using the framework is to speed things up, not to slow things down. So it introduces that issue of complexity. So frameworks kind of help, but kind of don't help. They're kind of, I don't know. I'd score them as maybe a kind of win just because they get rid of SQL injection everywhere and cross-site scripting everywhere. Firewalls. Hey, firewalls. I also remember I got into security 10 years ago, and I had my very first interview for being a security person. And my boss-to-be said to me, asked me to talk about security, and I talked about firewalls almost exclusively, because I thought that firewalls were something to do with security. I don't think that now, that's not clear. They help, but they're a very small piece of the puzzle. Unfortunately, well, and why? Everything is a web app. Everything is a web app. File transfer is a web app, chat is a web app, everything else, remote control is a web app. It's all web apps. So everything goes over 18443. And yes, you see people advertising their products saying, this is a firewall-friendly tool, which is kind of like saying this is a skull-friendly bullet. Goes straight through it. So how useful is your network firewall now? Well, it's still of use. I'm not saying take all the firewalls away. There were some security guys who came up with that, the Jericho project, came up with that a couple of years ago. They said, take all your firewalls away because they don't work anymore. Yeah, but they're still really useful for controlling complexity and for keeping the really obvious stuff off your network. So but unfortunately, one of the big expenditures for security these days is still firewalls. It's still network firewalls, it's SSL, and it's antivirus. And if you go around all three of those and say, right, how effective are they in actually protecting things? Right, well, antivirus. Those guys actually, I missed the presentation at B-Sites in London. There was a guy that came from here. They did a presentation on how to bypass AV. So it's a relatively well understood topic. If you go to any pen tester's forum, they will be talking about how to bypass AV. Because one of the things you're a pen tester and you're trying to do any exploitation is you need to get something that's not going to get picked up with the corporate AV. So they're doing it. The bad guys are definitely doing it. There's no question asked. They used to use a thing called VirusTotal, which is a way of scanning your exe file and saying, right, what antivirus engines will pick this up. Then they worked out that if you submit your file there, it gets sent to all the antivirus vendors, and very quickly they stopped doing that. So now they have their own ones. But antivirus is still something which people are well aware of how to bypass. It's not like it's ever going to protect you from everything. But again, I wouldn't say get rid of it. So firewalls are still there, but I would say that they're not really anything like as useful as they used to be. Tools. Tools has changed massively in 10 years. So, recent benchmark had 60 web app scanners, 60 individual commercial and open source web app scanners. Back 10 years ago, you'd be lucky to find NICTool, I think, maybe, Nmap, maybe. But nothing like the same. So we've got an embarrassment of tools now. Although I also think there's a slight problem with that, which is we have an embarrassment of tools because pen testers love rewriting a tool that already exists. Instead of extending what you've got, you should rewrite your own. The number of SQL injection scanners, so tools which will look for SQL injection and actually get to exploit it, is ridiculous. There's got to be 15 of them easy. So there's lots more tools, and that's good because it means that if people want to get access to them, there's a lot of open source stuff that actually can get you to a certain degree of testing your app, which is great. But they're only effective at finding certain classes of flaw. Luckily, the open source scanners won't tell you, hey, we can find everything, we can find the OWASP top 10. But if you ever have cause to go looking at commercial scanners, they will tell you exactly that. They will say, we can find everything in the OWASP top 10. And I will stand here and say that without extensive tuning, there is absolutely no chance that that is possible. Because one of the OWASP top 10 is a thing called insecure direct object reference, which is a fancy name for authorization flaw. So anything like, say I see a number, so user ID equals 5, and I change that to be 6. The thing about scanners, it doesn't know that the data it's got back is someone else's record. It just knows it's got different data. So it might tell you I've got different data by changing that parameter, but that be false positive central. You know, because every other time we're changing a numeric parameter isn't a security problem, would suddenly be flagged as a security problem. It's physically impossible for a scanner to do a good job of finding those unless you train it so heavily on the application that you might as well have done it manually. So that's the thing, they'll tell you, oh, well, we mean with training. But I've got to be honest with you and say, nah, I would never use it. I'd never use a tool for that. So tools are good for some things. They're good at cross-site scripting. They're good at SQL injection, and I would absolutely recommend people use them because I personally don't like testing 500 pages for the same flaw. It gets really boring really quickly. And a scanner is great, really boring, but they don't care about boring, they'll just go and scan. But they're only good for certain things. They're not good for, well, business logic, authorization bugs, things like that. They don't do it very well. You still have to have a manual person behind it. And a real risk behind that for AppSec is that I've seen a lot of companies where the developers get in a scanner. Someone says, I've got to do AppSec, so the security team buy them a web app scanning tool and point them at it, and then you get a manual tester and wonder why they've still got problems. And the answer is because they don't have the tool. So, in all this, with all these problems, and I came to thinking, well, how do you actually fix all this stuff? 10 years down the line, huge amounts of money spent, vast amounts of breaches. I mean, no one can argue that this year, definitively, between 21 Sony's, RSA, DigiNotar, Modo, carry on all day, just reeling off lists of breaches. This problem is in any way going away, and also you can argue it's not important. There was a good one in Canada, there's a company who issued prepaid Visa cards, and they got stitched up for $9 million in one day. Because the guys they broke in through, I believe it was a website hack, they've never cleared it up, it was a website hack, got in, found the system that issued pre-debit cards, created a holder blank cards, got all the guys to stand at cash machines around Eastern Europe, pulling out money, and got 9 million in one day. And the interesting thing is, that's the exact same thing that happened to another company in America about 2 years ago. So these guys are actually working out, hey, we just need to do web app hacking, and we can get into the external systems. And once we've seen one person do something successfully, we'll just go and do the exact same thing. Criminals are nothing if not predictable from that perspective. If it worked, why don't I do it? So it's important, and it's bad. How do you fix it? Regulation. First one, do you get the government? Do you say to the government, know what the industry is failing here. Industry has failed to fix this problem. It is affecting your citizens, and it is affecting your commerce, and it is affecting your critical national infrastructure. They're starting to talk about in various internet services being put as part of the government. I mean, no, the government has this concept of critical national infrastructure. These are things that are critical to the operation of the country. If these fail to, so like power, the police service, things like that, they're considered to be very, very important. People are starting to talk about adding websites to those, because websites are so important and the internet access is so important that if it fails, it affects the country. So at that point, is it a government issue? I actually done this presentation before, and I was thinking, well, actually, maybe it is a regulation issue. And then I got told by some guys who work for a company who make industrial machinery like SCADA systems, things like that. And they said, no, definitely not, because we've seen it in America. And what happens is if you have regulation, people will only fix the regulation. So all they will do is the bare minimum, they'll say, regulation says X, we'll do X, and all the money goes to that. And so unless the regulation is absolutely spot on accurate, and I've never seen anyone be able to write a regulation that's spot on, 100% applicable to everyone who's meant to do it, what will happen is money will go to there and it'll go nowhere else. And you'll end up seeing lots of bad stuff and a couple of good things. Is education the answer? Well, I do OWASP. So OWASP's an open source organisation, and they've been punting education out for 10 years. And has it had an impact, positive impact? I'd absolutely say yes. Is it fixing the problem? Well, evidently not. They've been going for 10 years, and it alone obviously cannot solve this problem. For every developer who gets educated on security, there are 100 who didn't bother. There are 100 who work in corporates, have worked in corporates for years, and aren't getting that message. So education alone, well, I think is absolutely vital. isn't going to solve the problem. So you come back to the last one I up here, and incidentally I'm more than happy to hear any other suggestions, because I will say none of these actually work before I get to the end of them. Is liability. Is liability the answer? Because if you think about it, if I have a website, so I've seen a situation where a company buys a web service from someone else. So they pay money to someone to develop a website. The customer then pays for a security test on that website. When they find lots of issues, and they always do, they then pay for the testers to come back and do it again. And in some cases, I've even seen the customer have to pay to have it fixed. So, from the supplier's perspective, why would he bother securing it? You know, he just wait for the first customer to come along and give him a test for free, pay to fix the issues, and pay for the retest. Fantastic, what a great business model. I don't have to worry about security. So, is the answer perhaps that you need software reliability? That if I sell someone a piece of software, or I sell them a service, and it turns out not to be fundamentally insecure, that I then owe them money. I'm liable in court. For most products you are. If you sell a car and it's fundamentally unsafe, you're going to end up in court being sued for that. You sell someone a building and it's fundamentally subject to going on fire and having no fire exits, you're going to be in trouble at that point and you're going to be in a court defending it. You sell someone software and it's got a bug, not only are you not liable, but you can actually make people pay for fixes. Oracle, for example, if you get Oracle, you download Oracle's products, or Sun, or any of these hardware vendors, and you don't have a valid support contract, you're no longer allowed to have fixes. So if your support contract's lapsed, you're not paying them money anymore. You could have paid for the hardware absolutely fair and square. You can't have fixes. It's going to be fundamentally secure, there's nothing you can do about it. Obviously very far from most products. The only thing that gives me pause on liability is if you dropped liability on software, on the software industry today, you suddenly said, bam, guess what guys, you're all now liable. I wouldn't want to think what would happen. They would all have to stop developing. They'd have to do what Microsoft did, except writ large. Spend the next 2 years saying, right, no new releases, no new shiny toys, no new mobile phones, no new web servers. We're just fixing stuff so that we don't get sued, because their lawyers would step in at that point and make very certain that that's what happened. So I hesitate to say liability is the answer. But outside of those three, it's not more boxes. I mean, IT security industry as a whole has been punting the mantra that buy this new box, put this new box somewhere on your network and it will solve a security problem for you. And we've seen how well that worked for the last 10 years. It doesn't. And in a lot of cases it makes it worse because all those boxes are software. So they've introduced more software into the environment which has more bugs, which leads to more problems. That isn't obviously the solution. Anyone else get any ideas?
Well, I'd like to go back over some of these points.
Sure.
It sounded like you said that education didn't really help, but it does make a difference, doesn't it?
It helps. It's just it's obviously not. Maybe we see more of it. I don't know. Maybe it's just not enough. It definitely helps because I've never. I do some work with developers trying to sort of explain security to them. I've never met a developer who didn't want to know. Who was like, no, I don't care. I don't care about how good my code is at the end of the day. Of course they do. You know, you'll be a developer and you go to work every day and say, I don't care about what I do. But, well, won't go anyway. But on the other hand, I think the problem is scale. It's trying to scale education and say, how do we get every developer up to the right level? Because it's expensive. And if you say to and this is the other problem, if you say to corporates, right now you're developing code and all is apparently well, you get the odd breach maybe, but there's one not quite ubiquitous, and you get a bad pen test report. Where's their incentive to spend the money? Microsoft did a study, they introduced security development practices about 10 years ago or started, they're still working on it. But they initially said it cost them 10% overhead on their products to introduce secure coding. The problem with that is, you say to a lot of software manufacturers, add 10% to your cost base. No, move on, next question.
You raised that same point, it's going to cost a lot of money, time, effort, with liability. No, we can't put liability in place because everybody has to stop developing for 2 years. But to get it more secure, it's going to take effort.
Yeah, absolutely. So it's a question of whether you think security is sufficiently important that it outweighs the commercial benefits. And the thing is, if you try to introduce the other point I was made, the lobbyists would be out like swarms in every major government, telling government about how they would kill the fragile economy because you're taking away the very valuable section of the economy by making them do this. They would be telling every story they could to every politician they could get their hands on to make it not happen, because it would really hurt them. I actually was at a conference last year, and actually the guy who used to run the security team at McAfee was presenting, And he actually stood up and said, it was not commercially viable for us to try and fix all the security bugs in our program. And that's the guy who works for McAfee, who are a security company. So if a security software provider doesn't think it's economically viable to do that, what chance does a guy who produces websites for any other industry have? Strangely enough, it isn't a bit of it that scares me most. The one that scares me most is SCADA. I am terribly scared of SCADA security, because SCADA security is the only one that can actually cause power plants to go funny on you. And trying to upgrade, you think about patch life cycles, you've got a Windows server, you can just patch it. You can go out there and go, bam, there's a bunch of patches. It might break, but probably not. Do a bit of testing. If you're running on a widget which sits in a power plant which rotates a dial which stops the sewage flooding out into the river, you want to be really sure that's not going to break when you patch it. The cost to patch, the time to patch, is much, much higher than the rest of the software industry. So that one, yeah, scary, yeah. The only thing that scared me more in recent security was when I heard that Boeing 747s have a Unix system on them. And apparently the flight engineers could tell net, not SSH, into it to change the engine parameters during flight. That scared me, I will admit. I didn't fancy flying on a 747 after that very much. But that was a guy who apparently worked in the avionics security industry, so he's not just some guy hypothesizing, he's saying, actually I've had this problem. Education, if I had to pick one of those three, and picked a horse which I'd like to see, I'd say education. But then it's the question of educating government to push, starting with universities, obviously. Well, schools maybe. Start with schools and universities, and saying, right, every computing course, for example, must have a strong security component. And then providing universities the resources to do that, because who's going to help them write those courses? Well, the industry or someone. But that's definitely the nicest of those three options, and the thing that would make most sense. It's just, again, comes right back down to money. Who's paying for it? Our government going to pay for it, universities going to pay for it, our corporations going to pay for it. I'd say it's in corporations' interest to pay for it, because it's in their interest to have developers who already know this stuff, so they don't have to pay for it. Yeah.
If we educated everyone, and if we were successful, would that not kill a large proportion of the pen testing industry?
Yes, and I'd be happy to see it. I'd be absolutely ecstatic. I'm a pen tester. I do this for a living.
Hey, that's our money you're talking about there.
I know, I am. But I would, if someone said to me, pen testing is a dead industry, and the next 20 years, because it would take something like that, is training developers and actually trying to move, I would far rather be working on that side of the house. Because if I have to see one more cross-site scripting, dumb cross-site scripting error the first time I start a text on Monday morning, I would, I'd rather not. I'd actually rather developers did this kind of stuff, because I'd get to spend more time finding more interesting bugs. So if they get all the dumb stuff, I could spend my 5 days or my 3 days, or whatever it might be, finding something a bit more interesting than that. Not putting a single quote in and having the website fall over, which happened the other day.
Do you think the design of the software is part of the problem?
Yes. I'd pick out SQL injection as a really good example of that. Why does a website, so a website's communicating with a database, usually just to pull data back and maybe to update data. Why can I do something like XP command shell, which allows you, so XP command shell is a SQL Server stored procedure that allows you to execute command programs. Why is the web app, why is the database allowing it to do that? Why doesn't it have one connection which only does data, and one different connection that comes in a different IP address, say, for control? It's the architecture as well. Oracle are terrible for this. Oracle database products have huge amounts of functionality that is totally unnecessary. But they sold it because the way Oracle sells something, or way is new features. So I want to sell you new features. I don't want to sell you, hey, this has got even less features. This thing's got no features at all, which is actually the best thing for security. Complexity. One of the things about frameworks is complexity kills security. You look at some of the great protocol bugs. Look at some of the protocols that have real problems. SSL is a good example. The number of implementation flaws in SSL is quite high, and the number of implementation flaws in any really complex protocol, the RFC is 2,000 pages deep. What are the chances of someone parsing that, coming to the same conclusion about how it should be implemented, and every single person who's implementing the RFC getting it right? Nil, no chance, can't be done. HTTP is a brilliant example. There was if you look at how one of the main things web developers can have problems with HTTP and how user agents implement HTTP is a nightmare. How do you implement various, you have to read the RFC, parse it and get it right, and then you add in JavaScript parsing and all sorts of other stuff. There's a good book called Web Application Obfuscation. Essentially he did that, he went through like the ASCII character 0255, got a program which printed them all out in various parts of URLs, so in the parameter, in the actual URL itself, after the URL, and said, how do different browsers react? And he worked out they all react completely differently. So if you write a web app, how are you going to get, you can't even predict how the user agent is going to interpret what you send them, let alone, so complexity is a real problem, and I think that's why you know, I'd say simple wins from that point of view. Simple is less likely to be insecure. Definitely when I'm testing things, simple stuff tends to be better understood and therefore, if you don't understand it, you can't secure it. If someone can't explain to you how their app works, there's no way it's going to be secure because they can't explain to you how it works. How do they know how to secure it? By extension, if you go to large corporates, I think if you went to most large corporates and said, tell me every single website that processes your data, has your branding on it, or is relevant to you. You went to most large corporates and said, give me that list today, right now, without going away and spending 5 weeks finding it. I think a lot of them would probably struggle because it's complexity. They don't know where everything is, and mainly, an IT is designed to be cheap. You know, most IT departments get gauged on how much money they spend or don't spend, and in that environment, things like security, you know, they're there, but they're not always a priority. Anyone else? Good. Questions? Nope. Cool. Thank you very much for that.